Hi, well here I am to help you out with the section 17.5, which has to do with the strength of acids when the acids are oxoacids. So let me just say a little bit about what an oxoacid is. It's just it's an acid that in which the hydrogen is bonded to an oxygen, and then the oxygen itself is bonded to some other typically inorganic atom, maybe nitrogen, in which case we'd have like nitric or nitrous acid, or maybe X could be selenium, in which case it'd be a selenium type of oxoacid, and so on. You can think of lots of examples. And here's the basic idea, is that because oxygen is a pretty electronegative element, it's going to draw electron density away from this X that makes this an oxoacid. So we'll say that it has a little bit of a negative charge, and that negative charge will have an electrostatic or a coulombic attraction to the slightly positively charged hydrogen, because after all, that hydrogen is going to leave as a proton, which is a +1 charge. So basically, the bigger delta minus, the weaker the acid. Okay? And so how does that really play out? And the way it plays out here is that the more oxygens have to share the electron density that's available from a certain X atom, the more that have to share, that means there's less to go around. So in this case, let's just compare H2SeO4 versus H2SeO3. Which one is the weaker acid? Okay, we'd have to say, okay, well, there's a selenium and it's got 4 oxygens around it, so those 4 oxygens have to share the extra charge that the selenium has to provide. In this case, with H2SeO3, only 3 oxygens have to share that electron density. So this one has a bigger, this one is going to have a bigger delta minus, okay, and therefore it's going to be a weaker acid, okay, a weaker acid. So in this case, we'd say, yep, the weaker acid is H2SeO3. If you want, it's pretty straightforward, but if you'd like to give HNO2 versus HNO3 a shot. Okay, well, in this case, obviously, the X is nitrogen, and I've drawn a couple of Lewis structures here. There's a Lewis structure for HNO2, and there's one for HNO3. Same idea applies. These oxygens are going to pull electron density away from that nitrogen. Here, what the nitrogen has to give is shared by 2 oxygens, and here, what the nitrogen has to give is shared by 3 oxygens. So it looks like this one should have a bigger delta minus, and therefore we'd expect this one to be the weaker acid. Okay, that one there is the weaker acid. Now, all the oxoacids work the same way. So essentially, all you really have to do is you have to look at the formula and say, whichever one of these oxoacids, for the same X atom, whichever one has more oxygens attached, fewer oxygens attached to it, that's the weaker acid. Whichever one has more oxygens attached to it, that's the stronger acid. Okay.